All right, let's get started. Thank you. So if you missed Janish's talk, you're going to be just a little behind because I'm not going to cover some of the things that he talked about, but that's okay. You're not going to miss anything. But in the interest of time, container security is really a huge topic. There's no way that I could cover everything that that you would want to know, but hopefully what I can do is kind of set the groundwork, give you kind of an understanding of all the different aspects of what we mean when we say container security, and then from there there's plenty of other resources that you can learn more, and hopefully that'll give you enough information to go on. It seems like it's still... Is this cable fully seated? Maybe that was it. All right, so you heard a little introduction. You saw the video. I won't belabor it. I do work in IBM's Cloud Platform Unit. However, I've been for the last 3 or 4 years very focused in the open source software area. So I've contributed to Docker. I'm a maintainer in the Docker engine. I work on Containerd, which if you saw Janish's talk, you know, there are all these other processes under the Docker engine that were actually running containers. I won't go into that today, but obviously there's a lot of activity in the open source world around Docker and Kubernetes and containers, and that's kind of my focus area. I'm also a Docker captain, which just means that Docker has recognized that I blog and speak and share information about Docker. And so that's a neat program to be a part of as well. So let's do just a brief kind of get everyone on the same page about containers. Who here uses containers in any way currently in your job? All right, great. So maybe half, maybe a little more than half, or we have some sleeping people that just haven't woken up since the last talk. So the sad news is containers aren't real. This is actually a quote I'm stealing from Jess Frizzell, a friend of mine who also worked at Docker, then Google, now at Microsoft. Janish gave a great example of this in his demos, that containers are made up of a set of various features in Linux. That the interesting thing is that they were all developed separately. There was no point in the history of Linux at which you know, someone said, hey, let's make this thing called containers. There were other Unix operating systems that did have a very specific concept called containers. Okay. All right, so as I said, containers are a set of a combination of features that were all developed separately. All of them have been used and tested in various ways, but it wasn't really till LXC and Docker came on the scene that there was really this kind of easy way for developers to use all these features together. And so C groups are resource utilization, so how much memory can a process have, how many CPUs can I use, how fast can I use the disk. Namespaces are things that actually isolate us from other processes on the system. So my mount namespace, there's something called user namespaces, network, IPC. Now there's even a C group namespace to add to the confusion. But these were ways that combining that with C groups, that's really what we've been calling containers for the last several years, whether you're using Docker or some other technology. Those pieces of software basically use these kernel features to provide you something that feels like a container. Over the years, security features have been added to that. You could think of some of these namespaces as being security features, but when I say security, I'm talking specifically about things like AppArmor, SE Linux, SecComp, and the Linux capabilities. And again, the prior talk, if you weren't here, it'll be on video at some point, but Janish did a great job of kind of explaining each of these aspects and how you can create containers using any combination of them. So we've said they're not real. They're also not perfect. Obviously, all these features were developed in Linux. If you know what a CVE is, you know, security issues happen in your Linux distribution. Obviously, Microsoft Windows. and other software packages declare these CVEs from time to time. All of the isolation features in Linux have had CVEs from time to time, which means some security researcher has found a way around these isolation primitives. And so we have to understand that containers, as much as we would like them to do what they say, sometimes there are bugs in software. I know that's hard to believe, but sometimes that happens. And therefore, containers have both been very popular in the last few years. There's been a lot of hype. There's also been a lot of sort of grumbling about, are we sure we should bet our business on containers? We understand VMs, we understand bare metal. These container things are new. We're not sure we should, trust that what they're really saying they do about isolating my process that they're really doing. So there's other things happening. Some people are kind of hedging their bets using things like lightweight virtualization. Windows containers has used that to some degree, although they also do have pure process isolation. Intel has something called Clear Containers. Hyper.sh is a startup that also makes it feel like you're running a container, but they're actually running a hypervisor with a kernel and your container in it. And then obviously beyond kind of those base features we just talked about, whether we're talking about namespaces or C groups, Docker, and then follow on kind of higher layers like Kubernetes have added kind of other pieces to this thing we call containers, whether we're talking about container images, like things you push to a registry, all kinds of container networking and software-based routing and special networking plugins. In the container world, we have, connections to storage and volumes and secrets. And then once we're talking about orchestration, who here uses anything like Kubernetes or Docker Swarm? All right, smaller group, maybe 10 to 20%. But if you've gotten into that arena, now you have other things to worry about, like how do my nodes talk to each other in a secure way? How do I make sure that a node can't join who is actually a bad actor and start to interrupt other work or get access to data they shouldn't have? So that kind of connects back to my original point. When we talk about container security, we're not just talking about the runtime like Docker being secure. We now have a lot of things to worry about security. So if we said that containers aren't real and they're not perfect, then why are we even using them? Why are they so popular? Obviously, the lightweight nature of containers has been very attractive. But really the features that we're looking for is this idea of isolating from the host. So in the traditional world, we ran a web server, we ran a database, and sometimes these things had conflicting needs, or if we ran them on the same system, their dependencies were different. Or one would have a runaway process using all the memory or using all the disk, and now we've messed up our database because our web server kind of went out of control. Obviously, there's also the idea of security from other tenants. So I want to run different workloads. And again, VMs have provided that isolation for a number of years, but VMs are much more heavyweight. And so the ability to run more containers on a single host, secured from other workloads, has been very attractive. Again, being able to tell a certain process that you can only use this much memory or this much disk is attractive. When we add in container images, a lot of people talk about a secure software supply chain. So the concept that I can know when I build something into a container, I can validate that it's immutable. So immutability is a popular concept in containers as well. But I can now sign containers. I can validate that nothing's changed in my delivery pipeline, that what actually goes to production was the same thing that was tested. And so we get that repeatability and reproducibility that comes from the container ecosystem. So again, we've established that containers are kind of a loose collection of concepts in Linux, and now Windows has some of those capabilities as well. We know they're not perfect, but they have a bunch of things that are valuable to us. And so really in the last few years, at this point our focus has been how can we make them secure so that operations can trust that using containers in production is secure. And so a lot of work has happened in the last few years. Things like application secrets. How do I get a database username and password securely into a container so that I'm not, sharing it in a variable or using it in a way that other processes can access it. Having runtimes that have better sane by default policies. And what I mean by that is instead of you having to go learn like Janos did how to set a Linux capability on a process or what a Linux capability is or how to block certain system calls or how to keep a container from being able to reboot the host. Having your container runtime know all those things and have people with expertise make sure that when your container runs, all those things are on by default. These are ways that we've really improved security. User namespaces is something I worked on in the Docker engine. That allows you to isolate even the user used in the container, even if it were to be able to see the host system, would have no access to any other files or content or privileges on the host. Again, we talked about AppArmor and SecComp. And then when we talk about orchestration, so things like node identity and cryptographic signing and TLS certificates between nodes. So in all these areas, the container ecosystem, whether we're talking about Docker or Kubernetes, there are a lot of people actively working to make security better by default. It's not just the open source projects, though. There are a huge number of security vendors who've appeared, whether it's startups or new companies, basically offering you software stacks that will provide a lot of these capabilities in a guided way. So I don't know if you've ever heard of Twistlock or Aqua Security. There's many other vendors who are now saying, you don't have to know everything about containers. We'll take that on and we'll give you dashboards and configuration wizards that will help you provide a secure environment for your containers in your test or deployment or production scenario. Toward the end of the talk, I'm going to talk about a few new things that are on their way. So we're going to talk about Project Grapheus, entitlements, some of the Kubernetes and Docker security improvements. But really, in a sense, hopefully what you come to at the end of the talk is you'll understand that defense in depth is really a valuable approach. And that means that I don't have to rely on just one thing to protect me and my containers. I should really have multiple levels of protection, whether we're talking about a SecComp profile or AppArmor profile or image signing or node security. All these things together should protect my system in a environment that I can trust. So the next few sections, we're going to look at kind of these different aspects of security. So we're going to talk about the host, the runtime, the images. Again, these are slides that have a lot of content because I wanted to at least give you a highlight of the different aspects. But each one of these could be a whole talk in and of itself. Obviously, we don't have time, and I don't want to bore you with more details than necessary. But understand that these are kind of the high-level concepts that you should understand as you approach container security. And on the right side, we'll kind of have a visual of all these layers in our system, whether we're running on an actual bare metal system or a VM. We're going to have a host operating system and a kernel. We're going to have a container runtime when we're talking about orchestration like Docker Swarm or Kubernetes or other offerings. Obviously that sits on top of your container runtime. Then you have a set of containers that are running, and those containers probably are running from images that were in a container registry like Docker Hub or a private registry that you're using. So we're going to start at the host down at the bottom. One of the interesting aspects of containers versus virtual machines is that containers are using a shared kernel. So on Linux, every container on the system, unlike a VM that each has its own operating system installed, you're sharing that same kernel, which means any kind of kernel exploit would effectively give someone access to all the other processes and therefore all the other containers on the host. So it's obviously important that your host operating system choices, how often that's patched, all the monitoring and management of that system should be aware of the importance of a secure environment. And so we'll give an example toward the end of the talk about things that people are doing with minimal OSs, secure OSs for just running containers. This also means, who knows what the privileged flag on Docker run is? Anyone ever used privileged? Oh, wow, just a few. So privileged is a way to say, hey, this container, when it runs, it has some software in it, and it seems to need a lot of privileges. It wants to write files here. It needs access to this over there. And I found out if I just use -- privilege, everything works. And usually that makes a developer happy because now they have a container that does what they wanted it to do. The problem is -- privilege turns off almost every security feature in containers. It also gives that container write access to all kinds of sensitive places in the file system. And so obviously from a host security standpoint, having privileged containers is a pretty wide open security hole that you probably only want to offer to highly trusted code. Again, if we're using containers, most of them are running as the root user. In fact, by default in Docker, if you just build an image, run it, it's running as the root user. It may have a lot of security kind of isolation around it, but if anyone was able to break out of that, that would likely mean they have root on your host system. And so again, using things like user namespaces that I talked about, or other ways to run your image as non-root is definitely valuable in protecting your host. And then you have to consider tenancy. So again, if it's just you on your laptop, this is not an issue. Once you're talking about running containers in production, maybe for your company or in a public cloud, you now have to worry about who else is on this system. What other containers are running here? Do I want to isolate team A from team B with different Docker engines, different VMs? And so there obviously are a lot of considerations there when I think about how can I protect my host, how much do I trust the code and the containers that are running. So that's a whirlwind tour of host concepts. Now let's talk about the images that people build. So when you build a Docker image, you probably are going to push it to a registry, and that's what someone's going to run when they execute a service, or just type Docker run on a command line. That image is going to be pulled, and obviously what's in that image can have a big effect on container security. What you want to have in container images is, first of all, you want it to have a concept that we call least privilege. And that means you want the least amount of content and the least amount of privileges necessary just to run what's in that container. And that means it's best if you don't use the root user. It means having only the libraries and the binaries that are needed to run the process in that container. And it means you should drop privileges. Now, Docker is already going to limit your capabilities in a container, but if you know you don't need more, you can even drop more capabilities or privilege on that container. How you actually build containers, who's ever written a Docker file or seen a Docker file? Great. So that's at least maybe half. So you know that first line is from and then the name of an image. Hopefully you're basing your images off a image that's well maintained, that whoever is providing it to you is worrying about whether there's CVE releases, patches, updates, and you'll want to rebuild your images regularly. Hopefully it's part of some kind of CI/CD pipeline, so that when your image builds, if there's an update, your images receive that update as you add your software and your code into that container. Effectively, don't treat containers like VMs. This is not something where you want to SSH into your container and do apt-get update. You actually want to be building containers on a regular basis, updating their contents. And again, there are some people who who even in their kind of DevOps processes will block their developers from using Docker Hub as a source. They'll have a sort of company-wide base image that everyone uses, and they'll have a team that makes sure that base image is minimal, that it's up to date, that it's secure. And so again, depending on your use cases, how you decide where to start from, what that base image is, and how you keep it up to date will be very important to the security of what's running in your container and the way that it's run in your scenario. A couple newer features in the last year and a half or so, at least in the Docker world, is the concept of image signing and provenance. There's a feature in Docker called Docker Content Trust. When you turn that on for a Docker engine, it will refuse to run any containers that haven't been signed. And then using software platforms like Docker's Enterprise Edition or other software, we'll look at LinuxKit, which is an open source project that also uses the Notary open source project to do this. But you can actually even tell a system, I'm only going to trust images that are signed with this key, and it has to come from this organization. And so again, this is another aspect of security. Once we're talking about building in a pipeline and having a trust measures in place, wanting to have your images signed and then proving that in certain environments only certain images can run, obviously is a great way to enforce making sure that the proper controls have been in place. So for example, maybe your CI/CD system will actually run tests and then sign with a testing key when those tests pass. And so there could be a set of stages where different keys are required to move to the next step. So that's all we have time for with image and content security. Runtime security, I've given entire talks on this topic. In fact, the idea for this talk was really to refresh a talk I shared several times in 2016 that really focused mainly on runtime security. So it was a lot about the topics from the earlier talk about how you use C groups, how you use namespaces, how you use seccomp and AppArmor. Again, we don't have time to go into all those details, but obviously once you've chosen Docker or Kubernetes as something you're going to base your production scenario on, you're going to want to understand how does that get deployed? Who has access to, for example, the Docker API? If you have Kubernetes, who has access to the dashboard? Because if someone has access to the dashboard, they can probably change a lot of things about your cluster. And so using role-based access control, making sure that the Docker API is not open to anyone, because once someone has access to the Docker API, they can stop containers, start containers, make changes, and effectively have root access to your host system, which we've already talked about. Who's providing your storage plugins or volume plugins or network plugins? Are there ways that people could access those in a way that would give them heightened access to your overall system? I've already mentioned Intel Clear Containers or Hyper.sh. Obviously, maybe in your case, if there's an area where you need to run untrusted code, you might choose a lightweight virtualization runtime that can improve the security of your runtime and orchestrator. And then how are secrets encrypted on the system? How are they delivered to containers? For example, a database access key, some kind of AWS key. Docker and Kubernetes both offer sort of complete secrets capabilities today that didn't exist a couple years ago, and people were doing all kinds of crazy things to try and get secure content into their containers. So again, that is an extremely short approach to container runtime security. There's a lot more you can learn there. There's a lot more you can dig into, but these are things you need to be aware of as you deploy a system, that it's not just as easy as installing Docker. There's a set of choices. There's a set of secure aspects to how you deploy it that will be important to the security of your system. Probably most important is that if security isn't usable, people probably aren't going to use it. developers don't have the time, most of them don't have the time to dig into each one of these different topics to understand all the capabilities and then come up with a system to actually enable and use these features. And so really, if security doesn't have usability, you're probably not going to have security at all. You know, they'll disable features. They'll use the -- privilege flag to get around all these issues that they're running into. Again, most of them are not going to have time. If you were in the keynote at the beginning of the day, there may even be kind of organizational pressure for them to just get their code working and in production, such that they're not going to have time to understand and enable a set of security features. And so you're either going to have a team of experts guiding developers, or even better, what if these systems were secure by default, out of the box, providing you all these layers of security so you don't have to spend time to learn those things and to do it yourself. So the issue with security is, who's going to decide what is secure in your environment, for your business, for, you know, the tenancy issues? Do you have multi-tenancy? Do you have untrusted and trusted workloads? I've already mentioned developers are going to turn off intrusive security that keeps them from doing their job. Again, there will be a lot of impacts to a DevOps mindset here, whether, you know, CI/CD, well, now I have to figure out, where does my upstream come from? Where am I getting images from? Do I have an image scanner available in my CI/CD pipeline that will actually scan images and tell me if there are unpatched CVEs? For example, I'm using an old version of Ubuntu and I haven't patched it for my containers. Again, a lot of these areas are being solved with vendor offerings from Twistlock or Aqua or other vendors. Even Docker has their own product that has image scanning. A lot of public clouds, so IBM Cloud, who I work for, and many other clouds are offering a private registry where you push your images, you'll get automatic scanning. So again, people are trying to offer you the tools to make this easy to have the capabilities you need for security. And there's been a lot of steps on the right path. So we have a lot of sane defaults in Docker today that weren't there a few years ago. So there's a seccomp profile built in to the Docker engine. You don't have to learn seccomp. You don't have to learn what it means to block certain system calls that your container shouldn't be using anyway. There's already an AppArmor profile that blocks many of the file mount points that you shouldn't be touching from a container. There are things people are doing in Kubernetes to allow you to simply label an image with an annotation and say, run this kind of image in a trusted sandbox, use lightweight virtualization, use higher security. So these are all steps that are helping provide developers and operations people with the tools they need to not have to learn all these areas of security and still be able to have secure container offerings. One example from Docker, so Docker has this swarm mode orchestration. Whoever has deployed TLS certificates, requested certificates, put them on the system, get a CA running, who's ever rotated certificates on a system? All right. So, you know, these are not things that you can't do. Obviously, you can learn and do them, but once you have a 10-node cluster or a 20-node cluster, or now let's talk about a 1,000-node cluster, how are you going to rotate certificates on all those systems and make sure that they all can talk to the master, and to know that if you get it wrong, the whole cluster basically falls apart? When Docker invented their swarm mode capabilities, they basically built in the certificate deployment. So the master became a CA. It generated certs for all the nodes that joined. It handles rotation. You can even set the rotation time to as little as a few minutes. So every few minutes, every node will get new certificates. Each node has a secure identifier. So again, things like this are providing you with tools that mean you don't have to, if this wasn't there, how many people, if they tried out Swarm on their kind of little test cluster, would have gone to the trouble of creating a CA and done all that work out of the box? Probably nobody. But because they built this into the system, you get it for free. And so these are the kinds of things that hopefully, as the container ecosystem continues to mature, these are things you will get for free without having to learn it on your own. And so Kubernetes has been doing similar things. Because Docker Swarm Mode is built into the engine, some of these features were easier to add. Kubernetes is more of a componentized system. You've got etcd running, you have the kubelet, you have the kube master. So some of these are more challenging, but there are ways that these same features are being offered in Kubernetes as well. So let me spend a few minutes here at the end to talk about some of the things that are coming. As I mentioned, we'll talk briefly about GrapheES. libentitlement is an interesting project. LinuxKit is an open source project from the Moby project out of Docker. And then I'll talk a little bit about annotations. So GrapheES is basically a metadata and server API for, and it's an open source project for handling the delivery and reporting of all the data around vulnerability and incidents. There is a huge list of vendors who've committed to publish in Grafana format. We were part of that: Google, Twistlock, Aqua, Red Hat, and many others. This means that if we all use GrapheES, the information about CVEs, what's in my container, what packages do I have, are they secure, are they not secure, can all be shared no matter what system we're running, no matter what software we're running. So this is a pretty new project, so we'll see where it goes. But hopefully this will solve the fact that, you know, I only use image scanners from this company and it doesn't talk to this container runtime or this orchestration platform. So hopefully GrapheES will create an open platform for sharing that data. Libentitlements. Who's ever had your Android or iOS phone ask you if a certain app can have a certain permission? Probably everybody, I hope. So in the Android community, libentitlements got some of its ideas from this concept, that it's really hard, unless you're Janos, to like go learn about all these capabilities and which seccomp, you know, which system calls should I allow or not allow. But in the Android world, they sort of made collections of those into things that we understand. I need to know about Wi-Fi. I need to access Bluetooth, or I need to change the network state. And so libentitlements uses the same concept to basically create these broad kind of container ideas. This container needs to do this. This container needs access to that part of the host. And the libentitlements library would translate that into seccomp profiles and AppArmor and which capabilities are needed. And so this is an interesting project we don't have time to talk much more about. I have the GitHub repo there listed at the bottom. I'll post these charts later so you can look into this more later. Annotations, it's an easy way in Kubernetes to basically annotate an image and say, this image I want it to run in a more trusted environment, or actually I don't trust this container. Please use a more secure way to run it. In this case, Creo, which is a Kubernetes runtime from Red Hat. If you put this annotation on your image, you can actually have it use Intel Clear Containers runtime to run that image. And again, there's more information on this if you search on Creo and Trusted Sandbox. LinuxKit kind of combines a lot of the things I've talked about in the last 30 minutes. LinuxKit is a distro image builder, so you can build a custom Linux distro using container images. And one of the cool things they do is they use image labels to specify the actual config for that image. So instead of the person running the container having to know which capabilities should it have, you know, how should the container be configured with the container runtime. They also use image signing and trust on by default. and they use a very minimal host OS where containers are all the services. So your SSH daemon is in a container. Your any other software you're running, your Redis cache, your web server are all running as containers. And so again, I've listed the GitHub projects here. It's an interesting project to look at that's trying to think about how to combine all these security concepts into a easy package way to look at this. So let's summarize briefly and then hopefully have a few minutes for questions. Security has improved vastly over the last few years. All the kind of knobs and bells and whistles that you need for security are there in the open source projects, but vendors and the communities are trying to provide ways that these are on by default to make it more usable, to make sure that you're secure when you're using containers. What can you do? Here's some things I think for you. Implementing defense in depth is very important. So having these layers such that if my setcop profile doesn't catch an issue, hopefully AppArmor will, or the fact that I have a read-only file system, or the fact that I'm not root, will control the blast radius or defend against something that's missed by one of the layers. And then I think it is great if you can learn, here's all the building blocks that containers are built on, the host, the runtime, the image. What does my platform provide? So with that, I'm out of time. And so thanks for your time. And do we have time for questions?